everyone. Welcome to the DCAI Summit. I'm Fabiana Clemente, and I'm Chief Data Officer and co-founder at YData. But today, I bring you a totally different topic. I guess we need to talk about communities, and specifically the Data-Centric AI Community. So you might ask yourself the question, now that you just saw the subtitle, right? So wait, what? Another community? Indeed, we have a lot of great communities in the AI and machine learning industry, but let me cover with you what is to be part of the data-centric AI community and what you can find and learn with us. But first, maybe let's start with a bit of story and context around data-centric AI. By now, we have all heard about the paradigm of data-centric AI. And that's all because of the famous talk of Andrew Ng in the beginning of 2021, from model-centric to data-centric. Andrew Ng describes data-centric AI as the AI development paradigm where data is seen as the iterative component of the equation composed by code, the ML models, and data. After all, it seems like investing in a proper data preparation flow delivers better results than only investing in tuning and optimizing our machine learning models. In other words, data cleaning and preparation isn't a pre-processing step, but rather an iterative step like machine learning models tuning. But is this concept really new? Well, probably not. If you go back to 96, CRISP-DM was published by then and was probably the first attempt to standardize data mining processes across the different industries. We can consider CRISP-DM that is probably the grandfather of the methodologies nowadays adopted in the machine learning industry. Interesting enough, it was created when data was small for our current standards, but both data understanding and data quality assessments combined with data preparation were already considered the core of the process. Many more projects, data ends, and hypes emerged since, and tuning around very similar concepts, but the truth is that none of them stuck. Interestingly enough, from the very early days, Google also developed on ensuring and focused on ensuring that they have high quality data to work with. So after all, they are Google, right? The proof is one of their acquisitions in 2010, a tool to clean up data before you generate insights from it, OpenRefine. Later on, the open source and renamed to OpenRefine, it was probably one of the first data cleaning projects for data science. This was huge, definitely. And some years later, SEMA introduced the importance of business feedback integration into any data science flow. With the big data hype, it was all about data and large volumes of it. That trend created a lot of new opportunities, trends, and toolings, but the one that I would like to emphasize is definitely data ops. Are the concept of architecturing data in a way that it can serve multiple stakeholders, and there's a process and governance to make sure it has quality and integrity. Although primarily applied for BI, it is a step towards a data centricity. When it comes to the niche of data science, the problems found around data are very different than the ones found in BI and analytics. Hence, much of the existing architecture did not solve data scientist problems. It was a period where many concepts emerged, some with very ugly names like data prep ops, that I'm not very proud of. But luckily for us, Andrew Ng came up with an interesting name to remind us that is really important in AI solution. And the internet applauded. No more data prep ops or the other ugly names. The data-centric AI movement was born. Well, but just 2 months later, and surprise, surprise, Google researchers published an article about measuring and describing the stakes on data quality in AI performance, where they describe the steps of data collection and labeling, as well as data cleaning and analysis, as the most impactful for the robustness and generalization of machine learning models. Or even better, the good old saying of garbage in, garbage out, it is already hinting that if you don't take care of your data, that don't expect to get results that go beyond the effort you have put into collecting, preparing, and developing your data set. Well, and the list goes on. Surely the concept behind the idea might not be new. But for me, what is innovative about this perspective is that in reality, where big data has taken the stage, and we have been convinced that the more data, the merrier, someone took a step back and shift the paradigm back from big data to smart data while introducing something new. The concept that data pipelines and data preparation can and should be also optimized and tuned. After all, not always big data means great data quality. Not always big data is available. And last but not the least, I would say, in 2020, I can safely say that this was a game changer for the AI industry. The launch of this community, the Data-Centric Community, also sparked a lot of events, articles, and reports, as well as new companies entering the space. Data-Centric AI went viral really fast, and now we are proudly hosting the first edition of the Data-Centric AI Summit. And because data-centric AI have only started and the trend and paradigm application is expected to grow, many are the questions and developments that will be seen in the artificial intelligence and machine learning space. But how can data practitioners keep up? The Data-Centric AI Community was launched in February 2022 with the mission of helping data practitioners in the data space to set and define their foundations towards the adoption of a data-centric paradigm. At the core of our community is knowledge sharing, cooperation, and the development of open source software that thrives the adoption of the AI development paradigm, centered around the quality of data. We live up to those values, so we expect to hear from us regarding news, articles, and papers about data-centric AI, as well as content produced by and for the community. Not less important, open source is at the heart of our community. So you can expect more projects and much more contributions. I invite you to join us in helping us building the future of DCAI. We have already started. Soon after the launch of the community, we started with the best data-centric definition contest. Our goal was to find a definition as clear and concise as possible, driven by the community itself. The decisive winner you can see on this slide. Data-centric AI is the process of building and testing AI systems by focusing on data-centric operations, meaning cleaning, cleansing, preprocessing, balancing, and augmentation, rather than model-centric operations, such as hyperparameter selection, architectural changes, so on. Big props to Marco, which was one of our members that came up with the best definition for data-centric AI. And because we have already come a long way, but we are just getting started, right? With just a few months of existence, we already surpassed the threshold of 1,000 Slack members and social media. We are gladly welcoming new members every day, answering questions and learning from each other. We also hosted the first of many webinars in May about real-world applications and examples of the data-centric AI paradigm. When it comes to open source tooling, we have gathered inputs from the community and listed 20 open source projects that will help you in your next project. If you want to know some more, let us know so we can give them a proper visibility. Also, when it comes to projects under our umbrella, we count with very popular ones, surpassing 10,000 GitHub stars, more than 1,500 forks, and millions of downloads. I would like to personally thank you, all of you, for all the support and contributions. This wouldn't be possible without your effort. Going into a bit more detail about our community projects, the one we should start with is the awesome Data-Centric AI. It's a young but growing fast, and we highly encourage you to contribute. In a nutshell, it is a repo of materials that help one not only getting started with data-centric AI, but also experts to improve their skills. It goes from data profiling to labeling and synthetic data generation, but other areas will come up soon. Another young project is the Why Data Quality that helps data scientists to expect data sets in more detail and receives warnings when something is not right. In a nutshell, it is a package that allows you to understand several behaviors on your data, such as whether you have missing at random data, whether you have problems in bias, for instance, or you have inconsistencies in your labels. It's definitely something that you should keep your eye on it. The next one is probably familiar to most of you. Pandas profiling enables the generation of a quality profiling with a single line of code. Yes, I'm very fan of Pandas profiling exactly because of that. In a single line of code, I can perform a full unsupervised and automated exploratory and data analysis of a data set. So how cool is this? And well, I guess with this, it's time to go for such a small demo. I hope you are ready to get your hands dirty and jump into coding for a little bit. Let's explore this library in more detail. I'm opening a Jupyter notebook or a Jupyter lab just because it's my preference or my IDE of preference to showcase this type of solutions. Pandas profiling has support for images, text, but also structured data. The examples I'm going to show you now are all from structured data, being the first one, tabular data, so data that has no time dependence. And the second one, which is a novelty and a very recent in our package, for time series or data that depends on time or has a time relation in between records. For the first one, I'm showcasing the use case or the example of the NASA data set on meteorites. So as you can see here, it's pretty easy and pretty straightforward to use Pandas profiling. I'm just importing my libraries. I'm also importing or downloading my data set. This data set is fairly small, or at least is not a huge or massive data set. In this case, I'm just, it's very handy to perform my profiling. So in a nutshell, after reading my data, I can just, and having Pandas profiling installed, I can just, even without saving the object, just referring that I want to perform a profile report out of my data frame. I can customize my very easily my report. So for instance, here I prefer to have an HTML that occupies the full window instead of having everything very nicely with very nice limits on the page. I can also ask or not for a progress bar, but I can change the title of my report, for example, and give it a very specific name for my business. I'm able to customize it in order to put a logo or an image on it. So I can change the themes or colors associated with the report, but most importantly, I can also control what type of information I want to show in my report. Let me just run this very quickly. And here, just for you to have a look. While this data set, or I'm generating the HTML for this data set, I'm going to start with also the time series example. This is probably the one that excites me the most. For this demo, I have used the USA air pollution data. So in a nutshell, this is a time series data set, and it includes several entities. So for each location, I have a station, or a station that is collecting the pollution data. So data about NO2, SO2 levels, for instance, or even ozone levels. And here, as I know that I have several locations, I also know that I have several time series, right? So it will be one per station. What I'm showing here today is exactly how you can handle those type of data sets, which are so common if we go and check in business. So if you go and check financial transactions, or if you even are checking, for example, trajectories of someone, or collected from customers, it is normal that you have most probably more than one time series per data set. So it's very important for you not only to have the understanding per time series, but also the understanding for all the entities you are dealing with. And that's why this example is so rich and interesting for you to follow. How can I then compare to, for example, the meteorites data set, which was tabular, generate a time series? Let's first see the tabular data set, so the tabular profiling, so we can really understand the differences afterwards when compared to a time dependence data. First and foremost, this is the exploratory or automated exploratory data analysis. As I mentioned, is totally unsupervised, which means there is no target kind of based analysis. All the variables are considered to be have the same importance or have the same role. For that reason, you won't see any extra analysis on the target one. The reports are all composed by an overview, variables, or detailed variables kind of view, an interactions view where you can understand how the different variables interact between each other, a correlations one with which is very in-depth, the different correlations from the Kramer V to the 5, for example, correlation metric, the missingness, so you can understand better how is your data in terms of missingness, how does it correlate between variables that have missingness, for instance, so you can understand better whether you have missing at random or not at random, for instance. And finally, a small sample of your data, so you can have a sneak peek, and the duplicate rows, or whether you have duplicate rows. If your data set does not have, of course, this section won't pop up. One of the very interesting proposals of pandas profiling is that you are able to control which sections you want to show in your report. For example, if you decide not to show the correlations, you can very easily configure in your one-liner whether you want correlations to be calculated, for instance. And most importantly, from all the correlation matrices, you can define whether you want to run all of them or just one, for instance. In this case, I've selected the default parameters for pandas profiling, but it's really flexible and will depend on your use case and your needs, of course. One section that I like the most besides, it's definitely the overview. So I can have right away a pretty good understanding of the number of variables that I have available, but I can also very easily understand the number of categories if I have only numerical variables, so the data types I have available. And afterwards, even more interesting, I do have a summary of the readiness or the status of my data in what concerns if I have problems on my data set. For instance, I can understand that I have a variable that is constant, which means that it's equal throughout all the data. So as a data scientist, I already know this variable won't bring me any information for a model. But then I do have also hints of high cardinality, and this might be important if I want to, for example, validate whether I'm in the presence of collinearity. This can tell me a lot how the data will or might not perform, and features extraction, features I can build with, features that I might want to select, for instance. I also have information about which variables have missingness and the percentage of it. So in a nutshell, you can have a very detailed profile of what is happening in your data, and it's a very summarized version. So you as a data scientist can right away know how much you have to go in terms of cleaning and preparing your data. Afterwards, if I want to, well, I saw that I have a lot of zeros, for instance, for some variables. Maybe I can go right away, look at those variables, and I can check their distribution or histograms. I can understand in depth the statistics associated with it, the most common values, for instance, etc., etc. In terms of interactions, well, I have very easily, I can just, experiment and see how for example, my mask does relate with my reflat. It's very interesting for you to see if there is a pattern in the data and the variables do have or do influence each other. The correlations, as I mentioned, have Spearmans, you have Pearson's, Kendall's, K, Kramer's V. You can even get the right understanding of what is this metric measuring. After all, the missing values are very detailed in terms of counting, in terms of matrix, how do they, in terms of the data set, where they are, if they are all together or not. The dendrogram to let us know whether there is a relation between the missingness, a sample or a sneak peek of the data, and last but not least, the records that are duplicate. And this is very important, just for you to know which ones you might be wanting to ditch from your data set, if preparing your data, of course. So, but this is the tabular data. And as I mentioned, we now also support for time series data. So let's have a look at the differences. Getting back to the air quality data set, I'm going to also call my one-liner to generate my report for my data set. But before that, I also want to understand how the records, the time series records, are spread across time, or they are organized through time. So in this case, I have a data set that has from Arizona. I only consider the state of Arizona. And for the state of Arizona, we have 5 different locations where air quality was measured. For each location, I have here, and this is a new feature in Pandas profiling, visualization that allows me to understand how the records, the time the measurements of air quality are spread across time. So I can see that there is one location that has no data in the beginning of my data set and only more towards the end of the year, for instance. There are others that have since the beginning and are equally distributed through time. But there are others that might have more records in some dates or some days, and some other days they have way less records. So this is interesting for me to understand how the data is spread across time and how the different, in this case, entities behave in terms of measurements through time. Now that I already have this pretty good overview, I want to run a report per location. So I will end up having 5 profile reports, and the difference between the time series one and the regular profiling one-liner is that I do have to activate my time series mode. And in a nutshell, besides the time series mode, it is also recommended that the sort by, meaning the variable that gives the time understanding, is also provided for the profile. So this is a way for us to sort by the data and ensure that the profile extracted is correct in terms of time evolution and analysis. So as you see, very easy, just one line of code. Is just really setting to true and starting the time series mode. And what will this mode deliver to you? Let me show you just one report. Here you can see I have one introduction, which is I have also, besides categoricals and numericals, now I have time series data. This type of variables are identified based on the autocorrelation or the presence of autocorrelation. They are identified automatically. And in a nutshell, this tells you that definitely this is a time series data set. Bear in mind, this type of calculation only happens if the time series mode is set to true. Also, I'm going to check my warnings again. So I do have a lot of high correlation here. There are a couple of variables that are constant, which I expected already. For example, the state of Arizona. If I'm going for the same location, the state of Arizona would be for sure a constant value. But also, as a new introduction or a new metric or a new warning, we have the non-stationarity and the seasonality. So it's important for you as a data scientist working with time series to know whether you are dealing with a stationary or not, because this does impact a lot the preparation that you have to do prior feeding your data to any model. Also, seasonality might be important. Do you keep the seasonality? Do you remove or extract the seasonality kind of element of your data? How does the seasonality kind of behaves? And that's exactly what we have introduced to dependence profiling. So as a time series practitioner, or in this case, a data scientist that is used to work with time series, this is the type of analysis that you have to do always with your data. So we just decided to automate it for you. And please, if you do have feedback, if you would like, as a time series practitioner, had more features, or you feel like you are missing some analysis, just let us know. Here, let me just show you how it looks like a time series variable in terms of analysis. So you can check, for example, instead of an histogram, you can see the time evolution of your series. This is highly useful for you to understand in a very broad strokes your data, but also you can have a more detailed interpretation of the autocorrelation of your series. For instance, you have access to the autocorrelation plot, but also the partial autocorrelation plot. This is very interesting if you want to know how does the autocorrelation behave in the data set, and also if there are lags that have higher importance, or if you have periodicity present as well. So this is the type of graphics and type of visualizations you will always have to generate when analyzing your autocorrelation. So definitely here you can find those already, and you can start already taking your notes. So what do you need to do from your data? All the rest of the report is pretty similar, but this is the first of many iterations of time series independence profiling. Well, now that we have already covered dependence profiling pretty well, let's get back to the presentation. Well, I hope you have enjoyed the hands-on piece, and we are ready for another cool package, synthetic data generation. Because the future will be synthetic, and it's not just me saying, Gartner and other institutions are already predicting this. So I couldn't miss out this topic. Synthetic data generation can be defined as artificial generated data that mimics the real world behavior, keeps its utility while, well, preserving privacy. And that's the best part of it, to be honest. This package can help you to kickstart your next project without the need of a big data set. So you can just simply generate one. The Y Data Synthetic provides an ecosystem of models and useful methods for you to generate synthetic data, which for me, it's definitely the new element in the data science toolkit. So is this a synthetic panda that we are seeing? Uh, just a joke. But this is just a mirror, but maybe it can be useful for you to learn the basics of synthetic data generation. As you can imagine, the synthetic data generated is expected to mirror your original one. And maybe in the future, I will hear about you. How is your experience with synthetic data? Hopefully. So maybe it's time for taking another look at the code or a hands-on experience. Now, and this time with Y Data Synthetic. Getting back here to my demos. Now that I've done the pandas profiling demo, it's time to showcase the Y Data Synthetic. But because synthetic data is, as in any other process of machine learning models, it's important for you to know that synthetic data must be part of a full data pipeline flow or an ecosystem where you have set different steps. So don't forget that the data analysis step or the data profiling step always pops up. And that's why in this demo, I start with a bit of the pandas profiling. It's exactly because first, you have to really know your data before just, starting right away to synthesize it. You might not have enough records. And when I say enough records, imagine that you have only 20 records or 20 individuals. Is that enough for synthetic data? Probably not. Or let's say that your data does not have variability. So why are you augmenting it? You have to take those things into consideration. So if you have missingness, the missingness also impacts your synthetic data generation. So a lot of machine learning models and synthetic data generation is not, it's just like any other machine learning model. You have to have that in consideration. So it does not work with missingness. So keep yourself close to data analysis and data profiling. And in my perspective, you can keep pandas profiling close to you for sure, because it will give you the amount of information that you need to make your synthetic data generation successful. And that is exactly what I've done here. I am considering the Kaggle dataset credit fraud. So it's a very standard and usual dataset being used. Here in this notebook, I just created the profile report for my credit data set. And now I'm going to have a look at it. One thing that I want to emphasize from this data set, and will be important for our analysis, is that I do have a target variable here. I know this is my target variable because I know the business, and this target variable is highly imbalanced. So this is a fraud kind of use case. So you might expect that you have less than 1% of the fraud events because they are rare, right? So when you are going to generate your synthetic data, you have to have this into account. So let's get back to the use case. For the synthetic data generation, as I mentioned, I need two informations, my numerical variables and my categoricals, as well as the missingness that is present. this data set, as I can see on my warnings, does not have any missingness embedded. So just high correlation and some duplicates, which for synthetic data generation does not worry me at all. So I won't have to do much work in terms of cleaning and preparing the data for my synthetic data generation process. But I do have to know which variables are categorical and which variables are numerical. In this case, I have 30 variables that are numerical and one that is just categorical. Now that I have this information, and just to double check, as I mentioned, my variable or target variable is highly imbalanced. So I have to have this into consideration when selecting my synthesizers. So, and as I mentioned, the wide data synthetic is an environment or an ecosystem of different algorithms and models and architectures for synthetic data generation. And that's exactly what you can find within wide data synthetic. Here in the project, and this is the GitHub repo that you can follow, and you can also, you are more than invited to give us a star and try it out for sure. We offer synthesizers for both regular and time series data. They do have different behaviors, so they do need different architectures for the synthesis. And in terms of the regular, because this data set does not have time dependence, we have plenty of models that we can choose from. So we have the conditional GAN, which is in a nutshell a conditional generative adversarial network that uses both, that is composed by two neural networks, the generator and the discriminator. If you are curious about GANs, we do have some articles at the community about how do they work, the most common challenges related with them, from the hyperparameter tuning like learning rate, for instance, or even how you can combine a discriminator, a generator, or several discriminators and several generators, the mode collapse, which is so famous, and so on and so forth. But for today, I won't be deep diving on those, but feel free to join us at the community and ask questions, read our articles, and become an expert in generative adversarial nets or in any method of synthetic data generation. But as I was telling you, we have the conditional GAN, we have the Kramer GAN, which uses the specific loss function, the Kramer function. Then we have the conditional WGAN with gradient penalty, which means I'm applying gradient penalty to the networks. And also I'm using the Wasserstein GAN loss. I also have the Dragon, the Vanilla GAN, the Wasserstein GAN without gradient penalty or being conditional. And I have the Wasserstein GAN with gradient penalty. So a variety of different models. How do I know which one to choose for my data set? Well, it will highly depend on the use case. The first question we did was, is it time series? Is it not? We already know it's not. So we already have our options more limited. Now, I emphasized a lot that we are dealing with a very imbalanced data set. This tells me that my network needs to be robust or needs to receive the information that there is a variable that is not balanced. And that information is very important for the network to not enter in mode collapse, which means only generating or giving more emphasis to one class than the other and only generating a certain behavior. That's something we want to avoid. We want the synthetic data to keep the variability of our initial information. So that's why we have to go, okay, for a stable network, which means we have to choose a loss function that helps me stabilize the training. That's why Wasserstein GAN, or in this case, the Wasserstein loss is one of the preferred ones, specifically with gradient penalty. That's one of the best choices, or one of the most secure choices you can do. But also, and because we have an imbalanced data set, I need, or I do recommend, to use the conditional version. What does the conditional version allow me to do? And that's what I'm going to show you. Allows me exactly to use the class, or in this case, the variable that is imbalanced, to condition the generation, which means my generator will know how to distinguish, and okay, now I'm learning from this class, or now I'm learning from the other one, which avoids a lot the problem of mode collapse. For example, for a data set like this, using the vanilla GAN would result just on the generation of the normal event. So no fraudulent event would be generated using the vanilla GAN. But on the other hand, with conditional GAN, we are ensuring that fraud events will be generated. And as you can see, the setup of a GAN here, it's with our package, is very straightforward. Of course, you still have to pass the hyperparameters such as learning rate, epochs, batch size. I'm emphasizing these ones because these are usually the ones that impact the most your results. Batch size and learning rate, most probably. Take into consideration that you have to set up the number of epochs, enough number of epochs, so the results of your GAN can converge. But if you have all that set up, it's just 2 lines, just like you do with any scikit-learning model. You instantiate the model, you set the training as the fit, you feed the data at the training time, and then you wait. In this case, I'm using a GPU acceleration device. So it took me 46 minutes to deal with more than 2 million of rows. And by the end of my training, I'm able to save my synthesizer. As you have noticed, the training of a synthesizer can take a lot of time. So I don't want to be training every time. So I always recommend you to save it as a pickle so you can reuse it to generate as many synthetic data records as you want and when you want. After that, I'm going to generate my synthetic samples. As I've trained the conditional one, this means I also have to pass my conditional vector, which is none other than my label. Here is where conditional GAN gets very interesting. You can control the type of sample you want to generate. So if you want to generate a sample of only frauds, you can, with the size that you want. It's just passing an array of just ones, for instance, and the network will only generate synthetic samples for the behavior of the frauds. But also I can do the opposites, right? So it's very interesting and very flexible. So you can, for example, if you want to debias a data set, you can just generate, provide a conditional class that is balanced, for instance. This is very interesting. And I do recommend you to do a lot of experimentations with it. And last but not the least, and it's still important, you should always check the quality of your synthetic data. As in any other model, the synthesizers need to be tuned, optimized. So keep the profiling close. Try to understand whether your data is behaving well and how well is behaving. That's why I have created both a profile for my real data, but I also have created a synthetic data profile for my synthetic data. This way allows me to measure the fidelity of my synthetic data against the real one. And after understanding what is failing on my synthetic data, I can go ahead back to the tunings or the hyperparameters of my model and tune them back so I can improve my synthetic data generation. Or I can get back to my data preparation and prepare it even better so I can optimize my synthetic data results. Well, this was in a nutshell both pandas profiling and my data synthetic. I hope you have enjoyed and you have tons of questions, enough to join us at the Data-Centric Community. Now, getting back to the presentation, I want to talk about the open source roadmap and what we have reserved for our open source packages. Starting with pandas profiling, we have predict the following features. One of them, the comparison of two data sets. This is highly useful for many different use cases, but being the most important one, probably when you are doing a split, for example, a training and a holdout split, and you want to know that your training population is representative, or even your holdout. So you can very easily compare both of them, but this also can be used for measuring drift throughout time, and so on and so forth. So the possibilities are endless. This is definitely one of the features we are most excited about. We also want to add more quality metrics. So we want to get the report more and more complete. And last but not the least, bringing a bit of skills to pandas profiling with Spark support. In what concerns Why Data Synthetic, we want its ease of use to be optimized, and also the onboarding at Why Data Synthetic simplified. With that, we want to release the official package documentation, but also we are planning to release 2 new GANs models. So the doppelganger for time series synthesis, and a new one, the Patagan for tabular one, being the Patagan, again, very focused on privacy purposes. But definitely we are always in need for some help. So would you like to contribute? That's my question to you. Check out our contribution guidelines or reach out in the community Slack, and we will be more than happy to onboard you. Definitely, as you can imagine, to develop an open source, it's about community. So the more you contribute, the better these tools will become. And one last request from our side, we also want to hear from you. Please give us your feedback. It is extremely important for us to keep things running and also improving them. I recommend you to go to this link, the engage.datacentricai.community, and write your thoughts. Or alternatively, you can count with GitHub issues, of course, or even Slack channels to give us your feedback. You never know, but your idea might be featured in the next roadmap. And of course, as a community, we have a lot more planned for you. We will continue our webinar series about the practical applications of DCAI and make it more frequent. The idea of the series is that nothing proves the point better than a good example. So we will invite our partners to demonstrate various use cases where improving the quality of data significantly improve the quality of the model. So stay tuned. Also, we constantly review numerous papers, articles, posts, and news on data-centric AI, and share the best pieces with you daily in Slack, LinkedIn, and Twitter. On top of that, we will be creating tutorials and recipes so you can get acquainted with these topics or improve your game. And challenges. The DCAI definition contest was just the first, but not the last. So expect to be challenged to put your skills to the test. Last but not the least, the new OSS projects are incubating, so I guess we'll have more exciting news for you very soon. And well, don't miss the chance to stay up to date with amazing content, community news, data-centric AI tooling, and funny memes. Sign up for our newsletter at the website, and also keep giving us feedback. I guess for today, this is all. So I hope to see you soon in any of these channels, LinkedIn, Twitter, but most importantly, Slack. You can find us on the website at the datacentricai.community. As I mentioned, LinkedIn and Twitter, but of course, Slack is where you can very easily find me. So I'll be happy to receive a message from your side, and I'll be happy to exchange some ideas and some thoughts about data-centric AI with you. Have a good day. Thank you.